Bismillahir Rahmanir Rahim. Assalamu alaikum wa rahmatullah. Peace and blessings upon you all. Dear students, today we come to the topic of CPM, which is the part of project management. We have already seen a lot of things about project management, which has these steps like initiate, plan, execute, and project close. And we do this to achieve specific goals and meet specific success criteria, whatever we want in this. Basically, managers are trying to use planning, scheduling, monitoring, and controlling large scale projects for 100 years, but it is now where we use the scientific techniques, okay, to solve our project management issues. And for this, we have two techniques. One is the critical path method, which we is the topic for today's lecture. And second is the PERT, project evaluation and review techniques. They are somewhat same, and they were used and uh, somewhat in the same time in a different places. But we will talk in this video critical path method, and in a second video we talk about the project evaluation and review technique. With that, our syllabus will come to end, and then we see if we have some missed topics left out or not, uh, or we can go for the revision. Now, before we start the CPM, we need to have some kind of a definitions, correct the spelling here. We need to have a critical path, which is the sequence of activities between project start, where the project starts and project ends, and we take about the longest time to complete all those nodes which are the longest time to complete. Okay, because if we have a longest time to complete here, that gives us later the minimum path which we can have to finish our project. We'll see it later. So we need to have some kind of mathematical calculations which are used for scheduling project activities. And it was in 1950 by Morgan R. Walker, who worked in the DuPont, which is a chemical company, and James E. Kelly of Remington Rand. This is another organization which is having the machines, which manufactures the machines. So it was first used in missile defense construction project. From then, CPM has been adopted in hardware and software products research and development and whatnot. Even though these days we use the Gantt chart, okay, more than CPM or even the PERT, but we will see what CPM is all about. So CPM is used in all kind of projects which are like these, like software development, construction, aerospace and defense, research projects, product development, and many more. So why are we using the CPM? According to Dr. Larry Bennett, that the benefits of CPM is that we identify the most important tasks. It helps to reduce the timelines and compares planned with actual. Okay, that is whatever you have planned and what is actual in the project, the timeline, and in case of money or whatever that is, or time it takes, the project takes, it gives us the indication of all of that. So in totality, there are 6 steps in critical path method. This is first is the specify each activity, because we need to specify each and every all the activities what the project constitute of. We need to know that. Then we need to establish dependencies between these activities. So because some activity is dependent on the other activity, so we need to know the sequence. That's called the dependencies. Then we will draw the network diagram, which we saw in the last video. And then we estimate activity completion time. What is the estimate of activity completion time in total time? And then we see what is the critical path, the longest path in the network diagram. Then we update the critical path diagram to show what progress we have made. So remember these 6 steps before we jump into some example. So what we do in a step first, that is specify each activity, is we see what are the major big chunk of tasks in your project. Then you divide that big chunk into subtasks, and that subtask into subtasks, so that you get each and all the activities of the project. So you will not go for the little work, you just go for the big work and divide it into two. For example, you have to, for example, create a house. So when you create a house, you will divide it into, say, creating the base, creating the body of the house, and creating the top portion of the house. Then creating the base, it will have the sub uh, activities or subtasks. Then those subtasks will have subtasks, and eventually we'll get all the activities of the project, right? Not only we need to have the all the activities of project, but we need to create the dependencies. That is my step second, because which job is dependent on the other job. So what is the predecessor of A? For example, I am working on, say, for example, A, which is some work I'm doing on making the house. But I know, say for example, you want to make windows. Now you are trying to make windows. It has some, say for example, E is the windows, but I have not yet created the base of the house. I have not created yet the walls of the house. I am talking about the windows, which is not possible. So I need to know the dependencies of the project, that they dependent on these other things. When they are done, say this was A, this was B. When A and B is done, then only then I can go for the E. I gonna create the windows. But if my no, neither the base is created nor the walls are created, I'm talking about windows, I'm going to execute Windows procedure, that's not gonna work, right? That's gonna only let us into the wait, because it has to wait, because it has the predecessors. The predecessors are the jobs which should be done before I can do that particular job, this particular job, for example, Windows here in this example. When you understood what activities you have and what precedences, what relationships have between them, and who is the predecessor of whom, then you can go for the network diagram, because you know which is the predecessor. So if, for example, task B, its predecessor is A, so I can make a network diagram. Or C has a predecessor A. In this case, if you see G, it has a predecessor E, for example. So or and so forth. So we can actually create a network diagram. This can be only done when you have identified two things. First, the activities. Second, their dependencies. You know the sequence, which has to be done after whom, right? Then you can draw the critical path analysis chart, or what we call as a network diagram, which we had done in the last video. Then after network diagram, you will try to see what is the estimate activity completion time, because out of the experience, because I told you in the beginning, the CPM and the PERT chart, the difference is in a PERT, that's probabilistic model. Here we have the deterministic model. Why? Because here we know the estimate, the time required to complete each activity. We know that. Okay. For example, if I manage the small projects, you will likely estimate time in days. But if you're working for the complex project, you may have to measure time in weeks. But you know it because it's a deterministic model where we know the time for an activity, how much time an activity takes. We know that, right? So by that we can create the estimate the activity completion time. Then after that, you have done with the activities, then dependencies, the network diagram, then the activity time. Then you can calculate the critical path, which is the crux of this CPM, critical path method. Okay, critical path method actually means to calculate the critical path. Here you will calculate the critical path, which is the longest path in this diagram. Okay, which you can just do by the two ways. Either you just eyeball your network diagram and simply identify the longest path. You can see which is the longest and just give double click or bold that path. That's it. Or you can add and use the CPM method, okay, which is to identify critical activities with two things, either forward pass or backward pass technique. So what is that forward pass and what is the backward pass? This is what we need to learn to solve a problem. Therein, for the forward pass and backward pass, what we do is we identify the earliest start time and earliest finish time, and we also find the latest start time and the latest finish time. So early start time and earliest finish time, latest start time and latest finish time. We need to know for each and every activity these things. And when we know these things, then we calculate the float or slack, what is called the float and slack. I'm giving you another word, that's float or slack. So what is that float and slack? We will come to know that, shortly. And after that, you have to update the critical path diagram to show the progress. This all will make sense when we come to the problem. But before that, we need to learn these terms a little bit. So the first term we have is what is called as a forward pass. So in a forward pass, we have, for example, this is my network, for example, and I'm seeing it's coming from here also. It's going here, for example, then it goes here, for example, and it's going here and say here. Okay, so I want to calculate what is the early start and early finish. I can do two ways. Either I go forward pass, that means I go from, this is my start and this is my finish, and I go from here to forward up to the finish. Either you go this way or that way, whatever, but you are going forward. So that's called the forward pass. In that case, you calculate early start time and early finish time. So I need to calculate for each and all the activities I have, okay, whatever the activities I have, I need to calculate the early start time and early finish time. I calculate it by moving forward through the network. And what I do is I will see who is the maximum out of these two. Okay, is this maximum or this maximum? Okay, when I calculate the maximum of these two, what we have in the beginning, start node, that is earliest start time for the start node is 0. We should know that earliest start time for the starting node is 0. Now if I talk about this node, what is the earliest start time of this node? I need to calculate that. Okay, so I will call it earliest start node of jth node, and this was the predecessor of it. So this is the ith node and this is jth node, for example. So earliest start of jth node, that's the node I am talking about right now, is the maximum, whatever the maximum of the earliest start node of ith node plus the cost of that activity. So this activity, say for instance, has activity cost 3 and this activity has cost 5. Okay, so you are going to the this node, for example, say this is B and this was A and this is C. You can go either through AB or either through CB also. C is also the predecessor of this B node, right? And I have to see what is the maximum, of its predecessor. Is 3 maximum or 5 maximum? The 5 is maximum. So I will take not 3, I will take 5 plus, that is my cost here, cost of it, that is 5 here, and the previous node's earliest start time, because if previous node is this, for example, then I will take the earliest start time of that 0. But if it is this one, say it was earliest start time was, it was, say for example, say it was 2 here, so it's going to be 2. Earliest start time for this is 2, so this will be 2 plus 5. Okay, so what I am saying is, if I have a particular node, listen carefully what I'm saying, I will repeat this thing in the video and with the examples you'll understand properly. I have this node, and on it has come from many nodes. For example, many nodes are the predecessors of it, and I will see who is the maximum out of these. Okay, and add that the cost, add the cost to the maximum. So we'll see this in a example also. So that will be called as the earliest start time. I will tell you in a while all these things properly, okay, with the diagram and actual question and the definitions. But just understand that if you are going to have the forward pass, only remember right now two things. If we are going for forward pass, okay, then I need to calculate earliest start time and earliest finish time. So earliest start time and earliest finish time, these two things I will calculate if I'm going from start to finish, that's forward pass. And this I am seeing the maximum. Remember this thing only for right now. Now if I go for the backward pass, for example, then I am calculating latest start time, not earliest start time, but latest start time and latest finish time. In the forward pass, I was seeing earliest start time and earliest finish time. Now in the backward pass, I am using latest start time and latest finish time. Okay, by going backward from the, if there are some network, I'm going backward from finish to start, I'm coming back. And here you don't see maximum, you see minimum. So remember this thing only, that if you go for the forward pass, then you are calculating earliest start time and earliest finish time, and you are trying to see the maximum here. And if you are going in a backward pass, then you are calculating the latest start time and latest finish time. What are these? I will just come to it. And here you will see the minimum. Only grab this much of information right now, that if you are calculating forward pass, that means you are going from start, from the beginning to the end. Then you calculate for each and every activity the earliest start time and earliest finish time. But if you're going for backward pass, that's like you're coming from end to the start, you're coming reverse, then you calculate latest start time and latest finish time, and in this scenario you will see the minimum. Remember this thing, and we go forward. And then we have one more thing that's called a float activity. It's also called the slack. We used to call it a slack or the float activity. This is how much we can adjust. We will see this, we'll understand it properly. But what is the float right now? It is a difference between the earliest and latest start time. Okay, because we have earliest start and earliest finish, then we have latest start and latest finish. Okay, if you have the difference between earliest and latest start, earliest start minus latest start, this comes from the backward pass and this comes from the forward pass. Okay, if you minus these two, or you minus the earliest and latest finish, or you minus these two, okay, you minus these two or you minus these two, whatever the answer is, that's called as a slack, or we call as a float. We need float. Why we need float? To calculate the critical path, okay, and thereby the critical activities. We will see that shortly. So what I'm saying is, we have forward pass where we move from start to end, and we calculate here early start time and early finish time. In backward pass, when we come from reverse, we say latest start and latest finish time, and we talk about the minimum at that time, and we calculate by, after calculating the early start and early finish and latest start and latest finish, we subtract the early start or the early latest start to get the slack or float, or we get the, if we minus the earliest and latest finishes, we get the float. Float means that you can adjust, you can float your deliverables. Now these are the steps when we do the forward pass through the network. We calculate, we start at the I at the beginning of the start node, and then we calculate first the earliest start time. So earliest start time is the maximum of the earliest finish time. Remember, this is the finish time. Okay, the maximum of the earliest. So the node, the beginning node, while from we start our network diagram, it has the earliest start time of 0 and earliest finish time of 0. You should understand that. Some books write it 1, then they later on minus it. So it doesn't make sense. So we should put up the 0 here. Okay, because that means earliest start time, that means I have not yet started at the 0. So that means earliest start time means कि आप अपना ये एक्टिविटी कब शुरू करोगे, ठीक है ना. सो पहली वाली तो आप शुरू करोगे बिल्कुल जब 0 टाइम होगा. सो इसका अर्लीस्ट स्टार्ट टाइम इज गोना बी 0. ओके, उसके बाद जो आपकी एक्टिविटीज है, फर्ज कीजिए ये एक्टिविटी है, उसके बाद ये एक्टिविटी है, उसके बाद मान लीजिए ये एक्टिविटी है, और उसके बाद आप फर्ज कीजिए ये तीसरी एक्टिविटी है और इसके ऊपर ये भी जा रही है, ये भी जा रही है, और ये हमारा एंड है, ठीक है ना. तो ये सिनेरियो है. आपको देखना है कि हर एक एक्टिविटी का मुझे देखना है दो चीजें. एक फिलहाल जो मैं फॉरवर्ड पास कर रहा हूँ, आगे जा रहा हूँ मैं, ठीक है ना. फॉरवर्ड पास में दो चीजें निकालनी है, अर्लीस्ट स्टार्ट टाइम एंड अर्लीस्ट finish time. Earliest start time, what we do in earliest start time is we see on this activity if it has more. For example, for this one there are two activities on it, so we have to see maximum of the finish times of both of these. So जो इसके predecessor है, say this is A, this is B, this is C, D and E. Now for the E, C and D is the predecessor. So इन दोनों में से whose finish time is greater, maximum? is its finish time greater or its finish time greater, then I can start it. What does it mean? आप दिमाग रखें कि मान लीजिए आपको ये प्रिंटिंग जॉब है, ठीक है, और ये इसका स्टैपल वगैरह करना है, मुझे स्टैपल करना है, उसके बाद मैं इसको बाइंड करना चाहता हूँ, ये बाइंडिंग काम है, ठीक है, आई वांट टू बाइंड. सो if I want to bind, the book is to be printed, it is to be stapled first, then I can go for the bind. So जाहिर सी बात है कि if प्रिंटिंग में 3 टाइम, इसका फिनिशिंग टाइम 3 है और इसका फिनिशिंग टाइम से फॉर एग्जांपल 4 है, तो फर्ज कीजिए मैं बाइंडिंग कर रहा हूँ 3 टाइम पे, मैं देख रहा हूँ भाई 3 टाइम इज द प्रिंटिंग टाइम, लेट अस गो फॉर बाइंडिंग, बट बाइंडिंग हैज टू वेट फॉर द staple also. So I have to see out of these two which one is the bigger, because I cannot start this activity unless all of the activities which are focusing on it, which are its predecessors, are not done. For example, I have this activity, and before that, this activity, this activity, this activity, and this activity, all are its predecessors. Okay. Say for example, this is the processing. So I have to sell. After that, I go to the sell activity. So, right, so this is the final product. Now I have to first do something, a lot of things into it. I have to mix it with something, I have to chop it, I have to bake it, I have to do a lot of things, etc., etc., and after that my final product is there and I can sell it. So should I sell it? Say for this one is sell only, okay, so can I sell it before? If this has time of 2, this has 3, it takes 4 times, it takes 5 times, and so on, whatever the time it takes. So I have to wait for the biggest time, because till then all the steps will be done. When all the steps will be done, then and only then I can go for this step, next step, right? So when all the predecessor activities are done, only then it makes sense to go for the next activity, right or not? So that is what we see, what is the earliest start time. So when will this node actually start? So this has to see the maximum out of all of these finish times, not start time but finish times. What are the finish times of all of the predecessor activities, and what is the maximum out of it? Because on at that time I can start this activity, before that I cannot start this activity. So simple thing is, so maximum of the earliest finish times of all the activities immediately preceding activity, यानी कि जो आपकी एक्टिविटी है उससे पहले जितनी भी एक्टिविटीज प्रेडिसेसर इसके जो हैं, उनका जो मैक्सिमम आपका फिनिश टाइम होगा, उसके बाद ही आपकी एक्टिविटी का स्टार्ट टाइम, अर्ली स्टार्ट टाइम लगेगा, ठीक है ना? और जो पहली वाली एक्टिविटी है उसका प्रेडिसेसर कोई नहीं है, तो उसका 0 हम अर्ली स्टार्ट टाइम रखते हैं. कुछ बुक्स 1 रखते हैं, फिर लास्ट में उनको माइनस करना पड़ता है, so we will not keep that, we will keep 0. Okay, so this is the earliest time an activity can begin without violation of immediate predecessor requirements. Because जो predecessor आपका requirement है वो ये है कि which says the predecessor should first finish, then and only then, because there is a relationship between the two. When the predecessor finishes, then you can move to the next node, right? So if the predecessor is not yet done, you cannot start this activity. The simple thing is, if you have to talk about the earliest start time of any node, you have to see what are the predecessors finish time. And if it is only one predecessor, for example I'm going here and its predecessor is only one, then there is no contention. I don't have to see maximum at all. I will just see what is its finish time. It finishes at 3, so that means I can start at 3. Okay, that's simple as it is, because my predecessor is done, I can do my job now. So this is my start time. For the beginning one, it is 0, because what will be the earliest start time? It is 0, because it doesn't have to wait for anybody, it just start at 0. So the 0 will be the earliest start time of the first node, and the next node, it will see if it is a single node, single activity, coming after it, then predecessor is only 1. Whatever is the finish time, that will be the start time of this activity. But if there's a contention that there are multiple predecessors, then I have to see which one finishes last, because I have to wait for each and every predecessor activity to finish first. So if it is finishing at time 3 and is finishing at time 5, I have to wait not at the 3 I can start, no, because this, if I start at 3, this is yet to be done, so I cannot start this activity before all the predecessors are done, so I have to start after 5 only. So my formula will be to see what is the maximum finish time of the predecessors, and that maximum will be my start time of this activity. Say that that's 5. Does it make sense? Hopefully you got it. Now, what will be the earliest finish time? What is the finish time? Finish time means whatever. So when will the activity finish, right? You have an activity, okay? When is this activity going to finish? Say this is my activity, this is a predecessor, and sorry, this one is the, I'm talking of this for example, and this is its predecessor activity, and I want when this activity will finish. So definitely it will see when the activity has started, what is its earliest start time when it has started, and how much time it's going to take, right? Because say for example it started at 5 and it takes 8 units of time, or whatever that cost is, whatever the cost is. So it has started at 5 and takes 8 units of time. So what is the finish time of it? So when will this going to be finished? That's going to be 8 plus 5, that's at 13 this is going to finish. So that is going to be my earliest finish time. So earliest finish time is nothing but earliest start time, okay, plus what are the time you have the completion of that estimated, estimated activity time, whatever the time is given in your table for that activity, just add them together, because what is the when you start and how much time you took for this activity, that is going to be your finish time. So that's called as the earliest finish time. So these two things we go when you go for the forward pass, okay. And by this, finish time, the earliest finish time, so we will see at the finish node whosoever has the maximum of the earliest finish time, that's going to be the project completion time. We'll see that later. That's quite, you can use a common sense to understand this. So when we do the backward pass through the network, okay, that means we move sequentially backward from finish node to the start node at a given node j. For example, we are at a node j, for example, some node j. Consider all activities ending at node j. For each of these activities, that means ij, because I am going in a backward manner, I will say what is my latest finish time. That is the minimum of the latest start times beginning at node j. So whatever is the minimum in the beginning, in the earliest start time and finish time, I was talking about the maximum, but here I'm talking about the minimum of the latest start time. Whatever the minimum is out of all of the beginning node at j, okay, that is going to be my latest finish time. I will come to it with the example to understand it properly. Right now, just understand that we go from backward and we see the minimum to see the latest finish time. Okay, so what we do by this is the latest time an activity can end without delaying the entire project. You just grab this information that this is the latest time an activity can end without delaying the entire project. Same way, from going backward, we can see the latest start time. So that is going to be whatever the calculated latest finish time is. We have calculated for the node latest finish time. We will see that by the example to understand it properly, minus time to complete activity. Whatever the time of that activity is, you minus with the finish time. Okay, like you did plus before here, in this here you see that the earliest start time plus time to complete is the finish time, and here it is reverse of it. It's the latest finish time minus time to complete activity ij. This is the latest time an activity can begin without delaying the entire project. I know these two is not clear yet. This will be clear when we go for the examples. Then the last step will be to calculate the float or a slack, that is whatever the latest start time is or earliest start time is, just minus them, and latest finish time minus earliest finish time minus them, whatever that is, it's going to be float. And what will be the critical path is a path of activities from the start node to the finish node with zero float time. So we'll see each and every activity and we see which one have the zero float time. So the zero float time will be my critical activities and that constitute my critical path. This thing also will be clear when we do the example. With this we end today's lecture, and what we have learned today is only the concepts. In the next video we take up the numericals and we apply the earliest start and earliest finish and latest start and latest finish and floats and all and slack variables, and we see how to calculate them using the numerical, and then this thing will be complete. So stay tuned for next video. Until then, ma salama.